Alright, unit test of Unit 5. The equation of ellipse, what's its center? It's -1, 7 because of the numerator of both the terms. -1, 7, what's the major radius? It's root 36 or 6. Minor radius is root 9, which is 3. Plot the foci of this ellipse. Okay, so the equation for the focal length of an ellipse is f squared equals the major length, which in this case is this here is 12, this here is 15. It's the x-axis, so it's a squared minus b squared. So the focal length equals 225 minus 144. That's 225 minus 144. That's 81. So the focal length, it's 9. You add or subtract 9 on the major radius. So move 9 units to this side and 9 units to this side. Nice. The equation. Okay, what are the foci? Okay, so again, the focal length formula. And I'll use a squared here because this term is larger. Okay, so f squared equals 67 minus 57. Get the focal length is equal to root 10. You add and since it's in the origin, you just add or subtract root 10 on the x value. So it's not this because that's y value, not this because I see 10, not root 10, not this either, so it has to be d. Nice. Write the equation. Okay, so from here, this is 6 and that is b. Okay, so I'll use it's y squared over b squared minus x squared over a squared equals 1, and not x squared because it's pointing to the top and bottom. So the 6 represents b, and 10 represents the focus. Okay, so f squared equals a squared plus b squared. I'm going to try to find out a here. So f squared is 100 because 10 squared is 100. A squared, that's what we're trying to find. Plus 36 because 6 squared is 36. 64 equals a squared because from subtracting 36 on both sides, and a should equal to 8. So substituting, we actually don't even need this because in the formula it has a squared. So it should just be y squared over 36 minus x squared over 64 equals 1. Y squared over 36 minus x squared over 64 equals 1. Nice. Which the following can represent the hyperbola. Y squared over 81 minus x squared over 49 equals 1. So it should point to top and bottom. So it's not b or d because they're pointing to the left and right. Because I see from that term there. And if x was equal to 0, y squared would equal to 81. Y would equal to plus or minus 9. So it would not be this one. It would have to be that one because it has to point to the top and bottom, and when x equals 0, the y must equal to 9 or -9. Write an equation for a flip. Okay, so the ellipse formula is x squared over a squared plus y squared over b squared equals 1. So, and the focal length is f squared equals a squared minus b squared. Okay, so it's towards the y direction, so the major length represents b. So I'll just rewrite this: b squared minus a squared. So the focal length is squared is 100 equals the major length minus a squared. That is no, this is 36. The focal length squared is 36. Foci at 36. Vertices at plus or minus 10. So this is 36 equals b squared 100 minus a squared. Subtract 100 both sides. Negative 64 equals negative a squared. Divide negative 1 on both sides. You get 64 equals a squared, and you don't need to simplify further because that's what's in the formula, and we're trying to find a formula. And then you just substitute. So x squared over, and this is at origin, so we don't need to worry about the numerators. X squared over 64 plus y squared over 100 equals 1. X squared 64 plus y squared over 100 equals this 1. Which ellipse is represented by, okay, so the center is at 4, negative 6. How do I know that? From the numerators here, when you set it to 0, you get 4, negative 6. And the magnitude of the horizontal axis is, the semi-minor radius is 3. I'm just right, horizontal. And the semi-major, this is the semi-major, and the semi-minor, the vertical one, is 2. So 4, negative 6. So A could be a candidate. B is not, because it's not at 4, negative 6. And D could also be a candidate. So we have horizontal semi-major axis with 3 units. That A looks like the better candidate, because D has a semi-major axis of what looks to be 1, 2, 3, 4, 5, 6, which is not what we're looking for. Alright. Plot the foci of the hyperbola represented by, okay, so f squared equals a squared plus b squared. We're trying to find the focal length, so f squared equals 9 plus 16. F squared equals 25. So the focal length is 5. You put that to the vertical axis. So you just add. You go up 5 from the origin, down 5 from the origin, down 5 from the origin, and that should be your answer. Okay, write the equation. Okay, so a hyperbola equation is. Okay, so this is the x. It has vertices at that. So I know it looks like this. So it's supposed to be x squared over a squared minus y squared over b squared equals 1. You substitute everything. X squared equals x squared over 4 minus y squared. We don't know b yet. So I used the focal length with the vertex to find it out. So the focus is at root 9. So wait, I'll write the formula first. So f squared equals a squared plus b squared for a hyperbola. Square root of 9 squared is just 9. A squared, so square root of 4 squared is 4 plus b squared. Subtract 4 from both sides. 5 was b squared. So this should be the equation. So x squared over 4 minus y squared minus y squared over 5 equals 1. Nice. Alright, that's the unit test for Unit 5. we're done with 5 units, and we have 1, 2, 3, 4, 5 units left. So basically halfway done. Even though it says 42% on the side, there's much more content and limiting continuity and probability and combinatorics. Okay, the next one, that's vectors.